Hi, good morning, everyone. I guess it has been a good morning with a lot of presentations. Maybe some of you are a bit tired right now, so I'll try to make this easy. Okay, so here, when you are interacting with ChatGPT, here sometimes feels a bit restrained because you don't quite know what you should put or not into the system, right? Like financial, mental health things you want to try and have the chat, but who really feels that resistance? That's one of the things I wanted to talk here. I was recently the head of AI at a mental health startup, and one of the products was this self-reflection agent. The problem is that we need to tell our users that they can trust us, right? We need them to be trusted in order for our product to be good. Because if people do not say what they really feel, people will not get the outcome that they will get in that situation, the best we could provide. And the idea was to build on this and see how far can we go then without sharing your data or with having a proof that your data is not being shared. Okay, who here likes comics? Not much? Okay. So I went to Nano Banana and he created this comic story for me and asked cheesy title, The Journal Dilemma. Then let me tell you the story. So here is Noah. Noah, he wants to make a journal entry and he wants to talk about Lily. What happens is that Lily works there, right? And he writes the entry and somehow Lily is going through the logs and sees Noah's post. This is a bit of a far-fetched situation, but the thing is that people in companies, they have access to things that we hold intimate. And it might not be any evil necessarily that people feel, but it's just that sometimes it comes up to them and we might not feel comfortable with that. Now, what is the issue here? I wrote a vlog on mentioning what is this plaintext and how you go from this to encryption end to end, is that everything is open in the server. And it can be what we call encrypted at rest, but there probably someone has a key. So it's not quite that of a safe assumption. If there's some kind of spin or breach, if the breach is considerate, if the attacker gets access to the machine rather than necessarily just the DB, but the machine with the code running, then he can seal the crypto, whatever is there. So how can we fix this, right? Who here knows Signal, Proton, and even standard nodes? Standard nodes, it's a bit of the same feel that they give you the client, they open the client and they say, look, you can look through here and you can be assured that your data is encrypted. So they did just that. And then Lily storms into Caroline's office, which is a CEO, and says, we shipped the end-to-end encryption feature. And then Caroline just replies, okay, so now we can work on our AI features. But what data are you going to apply the AI to now, right? But it becomes a bit complex. But Lily, she feels confident and she'll get the workaround. So let's go. So first, living on the edge, right? Nowadays, when we talk about private AI, we talk about having things locally, a Llama or even LM Studio, those kind of easy to use where you can deploy a model. Why not? There are some good solutions appearing to have even in your mobile phones. You have Google AI Edge, Llama Edge, these good inference engines, and you have really good optimized small models. They are becoming really good, and they are still around 700 megas or 1 gig of storage space, and maybe 4 to 10 gigabytes, even if it's the lower quantization. So it's still a burden for the phone to use. Now, the thing is, the model itself gets exposed, right? And all the logic that Caroline and Lily worked so hard to build is not protected. So then people can go, they can replicate somewhat. It might be difficult to say that's my model or that was put on my model. So this is Mario, and he just wants to get his new business idea as cheap as possible. Now, so we have two secrets to protect. We have Noah's data, and you have Caroline's model, or it can even be her hardness codes or things like that, which is even more complicated to get. Queer, is everybody tracking things up until here? So why we need to also preserve the company itself, right? They provide the value, they work hard for this, and they can't have their things like just immediately copied over. So now, what if, just throwing out, what if we compute on encrypted data? And it really turns out that is actually possible. So the idea is that you would encrypt the input data. So imagine you have this data point here, you encrypt it, and you provide some linear operations on it. Then you provide the reverse operation, and you have here in your landscape the result. This works. The thing is, there are some catches. These operations that occur in the encrypted space, they are quantized. So weights and inputs, they need to be quantized. So there's always some loss. So this 3 times 2 plus 2 times 5 is equal to 16, but it's not quite 16, although it's larger than that. And the thing is, this works with linear operations, even though the neural networks, they are mostly linear operations. There are a lot of these activation functions that are not at all. And in here, there are some approximations that can be done, but they are expensive computationally. So we can use this, but the depth of the language model just breaks into it. Here is, I tried this just with gradient boosting to classify sentiment in journal entries. And that still took a long time to compute. Now, part 3, hardware isolated enclaves. So imagine this. Caroline has a box. She gives the box to Noah. And she says, you can look at the box. That's what the box contains. Now, what we will do is you put your data inside, you lock it, the data will be transformed because you know what's inside, and then you can get the output. And maybe think there's a little mouse in the box, he puts the cheese in, and then he gets the eaten cheese in a way. So this is the base idea. You have your data, and it gets processed there in the server. And the idea is that the RAM is ciphered. So even if you put this into Azure, AWS, Google Cloud, the hypervisors, they cannot see the data. Then you provide the operation inputs. So the thing is, here you have a lot more to validate, and it is more also the step in itself, it's more complex. So Caroline exposes the code. She tells Noah, this is the code, it compiles, and after compilation we have this hash. And when this machine is running, you can see that it's running on that machine because there's one private key per chip, and the HVM has then another key that depends on that private key. So the user can know based on signature that key is running a TEE, trusted execution environment, and that TEE, the base image it has loaded, was compiled to some hash, or here you can do different steps to make that work. And the idea is that the client then verifies if it came from that machine and if the code is what it's reported to. Now, what is the big difference here? In FHE, everything is encrypted. So it's much more the signal example. The data goes encrypted, you do things on it, and those things, they stay on your servers if you are talking about the company side, and that's it. Now, on TEE, you need to trust whoever is making these chips. So you need to trust AMD or Intel that they say this key that is in this chip is one of a kind and it's there. So you have to trust the chip vendors, but you don't necessarily need to trust the chip vendor employees. You just need to trust that whoever manufactures does this the way they intended to, which is a much safer, I would say, approach than just having everything open or with the key in the server. So what can you use today? There are these solutions, which is Red Pill and Tinfoil AI. These work as endpoints, and I think Red Pill also has a chat interface. The idea is that you do this verification, or you let it run and trust other people to say it does what it promises. You encrypt what you want to send, and then you send it, and you get the response. A bit like an endpoint. Just be careful that because Red Pill, it does provide some services that are not encrypted, they just do this mangling so that the server does not know who it came from or from which IP. So they have this endpoints that are their TEEs and external ones that they just anonymize the source. And still a problem because we haven't yet solved Caroline's problem. So internal use works if she works in a healthcare or other approaches, or if she has data, internal company data that she doesn't want to share, she can use the solutions. But serving user yet is not solved here. And this is where we need to build on top of what is there. And there are also some companies doing this. I drafted here a version, I think simpler version of what can be done and how, which I'll show you. So we have 3 people and there's 1 machine. So here I portrayed Mario as sysadmin in the hypervisor. Noah is writing his journal entries and he wants them to be private. And Caroline, she spent a lot of effort making all of those weights and hardness codes, and she does not want to have that shared. So we start with some local user. Maybe the data does not even need to live here. Okay, it can be on the client. And maybe we want here some local tools, because if we have different journal entries and we are searching through different journal entries and things like that, then maybe we want the tool to be local and not just sending everything we have. And then there's this host controlled by the hypervisor and this confidential virtual machine, right? So this is the hypervisor or the machine creates this virtual machine inside, and it's only in the virtual machine that the memory is encrypted, not outside. And Caroline, she put up this launcher. So it's a software that runs when the CVM boots. And there no one can see that it does not have SSH access. It does not do outbound requests, things like that. Or if it does outbound requests, it's on specific key terms and you can see which those are. And the first step is just the user needs to see, okay, am I running on this confidential machine, number 1? And second, is it running the published launcher that I was promised? Okay, this is the two-step verification. Then you can start chatting with the launcher code, so with the service running inside. And Caroline, she can put her model engine here, inference engine, and she has to get a way to get some weights into there. And the weights, they are mostly numbers. There's not a big issue if the format is the correct one, right? That she just tells Noah, okay, I'm going to load this that you don't know. But there is a problem with hardness code, right? She has here some custom logic, some closed tools. Who knows if this is not sending things to the outside? She tells Noah, okay, so we need also to run this. And Noah says, no, we can't have that, right? So what we need is some kind of sandbox. The idea is that there's no network, no file system, and the memory is bounded. And then Caroline tells Noah, okay, then we just make sure there are some gated calls here. And that's the interface out of the sandbox. And I'll put my code here. And we need to get it from somewhere. Issue now is how to do this. We cannot put the keys to where this is. It probably cannot be also open in the network. So here this is where I started also trying to make this work. I have here a Git repo where I've been working with this. So this is what we got, right? And I'm using the GCP because they have a good way of solving this problem. So we put our private data that Noah can see here. They're in the cloud storage, and the machine gets it encrypted. Okay, they are encrypted there. And there's also this resource in Google Cloud, which is a key management system. And it ties up with this confidential space, which is what Google Cloud calls to their confidential VM stack. Not necessarily all confidential VMs need to be in confidential space, but there's a lot of operations that make it easier. And then there's some kind of verification that go here that says if the machine is a TEE, if it's running our launcher, and also if it is our project identity. So within Google Clouds, it's my project that it's running that, and it's this service user that can access the key. And then the Cloud KMS, based on that gateway, gets the key. Then you unlock, and there you have it, the harness and the model. And I also then added more things. For example, you can ask for a summary, you can ask for embeddings. I will try, since we have time, to show it running, and hopefully things will not break. So here, the idea is that I just pre-fill this entry here, which is a new one. We have already this, and we can, for example, save this entry. It will then compute. It's here computing some details for it. For example, this one that was older as the summarization, it also some embeddings done. So that if I come here to the companion and I ask, what is Maya doing? Then it can select the features that have the closest vectors. So the embeddings, they are done in the server side because they are more expensive. The vector search in itself is done in the user because if it does not have many entries, then it's not also that big of an issue. And hopefully this will work. It will take time because for me to use the GPUs, it was also more expensive to have them running. And okay, here it is. And it has a different memory, NVIDIA. So there's a different attestation problems. That's more complexity. And this is it. Hopefully this compiled to something, but yeah, this is what the summarization sometimes is not kick in. Still need to refine. Anyway, if you want to use these today, there's ConcreteML that's using machine learning for FHE. If you have a simple model, not a language model, but if you want to test it out, it's also an interesting project to do. Red Pill and Tinfoil AI, they are the ones we mentioned. Between the two, Red Pill might be the easiest one to use as a user because it has direct interface. Tinfoil AI, it sounded to me more secure in terms of how they operate and things. Now, there's also a company called Confidential AI, and I want to talk about them here because everything that I've been done in the last slide, they are doing it in a more robust way. And the issue with these solutions is that if each one of us does their own solutions, there's a lot of work that goes into auditing, right? If we have 100 signals, then we have 100 client codes that expert people need to see, to audit it, to check that, no, this really does what it promises. And this is it. Thank you then, everyone.